Hi everyone, welcome to this video. In this one, I wanted to go over the most common Nmap port scanning, and the reason you want to watch the video is I will also do a Wireshark packet capture, and I'm going to show you the details of the packets that is going to give you a deeper understanding of what happens when you use different types of scans with Nmap. Now, Nmap is definitely the most popular scanners for security professionals. So if you are in the security industry, most likely that at least you have heard about it. And I have several other videos previously where we have used the Metasploit, and there are a whole bunch of scanners for both TCP scans and your SYN scans that comes with the auxiliary module. In this one, we are not gonna be working with the Metasploit console. We'll directly use Nmap. Now, if you use Nmap directly, then it's really a two-step process if you want to bring in all the data back to a Metasploit framework. First, you will run the Nmap with the OX flag and output to a file, and then just use the db import command inside the Metasploit to bring those data back to the Metasploit. Now, I already have some videos for this. Please watch, and I'll put the link in the description. So three main scans that we can look at today. One would be the TCP scans. This is probably the most common scan, okay, and most reliable. However, since you need a full connection and you have to have the three-way handshake done, which is done by the SYN-SYNACK and ACK, so you're going to send a SYN packet. The attack, the host machine, the machine you're attacking is going to send back a SYN-ACK packet, and at the end, you will send a final ACK message to establish to complete the three-way handshake. Okay. Simply, the command would look like that. Nmap, then S scan type is T, so it's using the TCP protocol, a full scan, and then you can specify the number of range of port that you want to scan. You provide the IP address or a CIDR, and that's about it. Now, one of the drawback of this scan, if you have a firewall in the system, it will be able to identify that you're trying to do a TCP full scan. Now, we'll do the hands-on in a minute. Let's just talk about the SYN-SCAN for a second. SYN-SCAN is really half open scan. Okay, it's also known as the stealth scan. It is difficult to detect by your IPS IDs or firewall devices sometimes if they're misconfigured. And TCP full scan, it uses the operating system's network function. So you may not need administrative privilege to run TCP scan, but for the SYN-SCAN, it actually generates the raw IP packets, and it will send the packet, then it monitors the response. And if it gets a response, like if it gets the SYN-ACK response, okay, then it does not send the last ACK packet, it just resets the connection. Okay. And the scan would look like something like this. Nmap, instead of ST, we have S and then S. Now UDP scans a connection list. So nothing is sent back, neither a ACK packet or a reset packet. We are not going to send anything. It's a completely connectionless. So what happens, Nmap creates a 0 byte UDP packet and it's sent to the target machine. And if the target machine says, hey, ICMP port unreachable, okay, then we know the port is closed. But if there is no message receives, no response, then UDP scan reports the packet to be open. Okay, but this can lead to a lot of false positive. So if the port is closed, you get a message back like ICMP port unreachable, which is good. So your scanner is saying, hey, that port is closed. But if you don't get any response, then it considers the port to be open. Now, as I said, this can lead to false positive because there may be firewall who will just drop a packet and it will not send you any information back. Okay. So let's get started with these three, and then we'll quickly look at a couple of other uh, scans and options that I typically really like. One would be dash O. This option with Nmap, it will show you the version of the operating system in great detail. And sometimes I also use the version detection, very useful. And this one will also give you the version of various services that are running. So for example, if you have SSH server, what is the version of it? If you have Apache server running, what is the version of it? You will be able to get those kind of information. And last but not the least thing that I want to mention, that there is a way that you can try to decoy that you are doing a scan. It will really not hide your IP, but you can add a whole bunch of other fake IPs in the mix. So when you send the packet, if there's a firewall, the firewall will think, okay, someone is trying to scan me from all these IPs. Maybe this is the only IP that is real, that's yours. But Nmap will send the packets in a way it will appear to the firewall that a whole bunch of other IPs are actually trying to scan the network. So it's a decoy scan that setting is available. If you never use it, give it a try. With that, let's see how we can do the hands-on. Now what I have here, I have a Metasploitable 3, which is running here, and I have an internal IP address 192.168.123, and I have a Kali box, which is I'm also running, and this one has the IP address in the same range. So we're going to look at some stuff. We'll start with the TCP scan. Now before we do anything, what I like to do, I'll just start up the version. Okay. And once I have the Wireshark running, I'm just going to start this one. Okay. Now I go back to this console, and what I'll do, I'll just run as sudo and then nmap. And what I'll do, I'll scan for a TCP based scan, so ST, and I'll just provide the IP address 192.168.1.1.23. That's the IP address of the Metasploitable machine that I have. So if I run this one, it's asking me for the sudo password. Let's provide the password, and it is now starting the scan. Okay, it may take few seconds, and it said in 4.252 seconds the scan is completely done. Now before you review this, let's just go ahead and stop our scan. We don't need anything else. Okay, now let's come back over here. First look at the result that we have. Okay, the scan, as you see, it was very fast. Okay, only took 4.52 seconds. A very reliable scan. And by default, since I didn't provide any port, it scanned up to 1000 ports. Okay, if you wanted to expand the port, I'll have to provide uh, my command with -p options. So I'll probably provide it over here, -p. Let's say I want to scan 0 to 5000. Okay, I would have to do that. Okay, then I'll have to enter the command again, and this time you might see that there are some other ports that might show up, things like that. Now uh, if we analyze these packets, I'm going to stop this scan and just look at these packets just a little, the results that we have. So what I'm seeing from these results, by default, okay, these are all the ports that your Nmap has given us. Okay, it's saying there were 991 ports. It had no response, and it's telling me that port 21 is for FTP, that is open, SSH is open, your HTTP port is open. So these two are really good news because they're unencrypted, right? SSH could be a good news. You can start brute forcing. 445, typically your file share Samba that's running on that service. There is some other like point-to-point protocol. Your MySQL running is 3306. You have a proxy server, some kind of proxy running on 8080, and you also have something intermapper running on 8181. Okay, now let's look at so that's good information. Okay, it's telling me which ports are open and what services might be running. Okay, now let's analyze our packets that we captured from that packet. So what you're seeing here, okay, if I look at there are tons and tons and tons of SYN packets. So what is going on? So as I said, this is the SYN-SYNACK-ACK. So you're in map, and this is my IP address to Kali box. It's sending this IP hundreds of different packets, and it's just going through the number of ports it can send packet to, and it's sending the SYN packet and it's waiting for a response. Okay. Now, if you go through this file could be really long. And look at this. This is something where he is sending packets. So my colleague is sending to the metasploitable box 3 to the port 80. Since we know there is something running, I'm getting a response back from 80, and it is telling. So in this case, I have the SYN packet sent here, then ACK packet, then at the end, so if I follow this packet, okay, so you will have this complete picture what is going on, right? So you 105, okay, that is my Kali machine. It's sent a SYN packet. Your metasploitable sent me back a SYNACK packet. Then the Kali again at the end sent the ACK packet. And so a full handshake process got completed, right? And it looks like it also sent a reset packet at the end, and it said, hey, I'm done with you. You can now close the connection gracefully. Okay, so what happened in this scenario, you have a full connection established, right? So let's close this. And so if you want to quickly find out, okay, say if you wanted to see what happened to port 445, you can possibly use some of the uh, filters. So let's say TCP port, and if I say double equal to 445, and if I hit enter, you see again I have the same behavior, because again in here it's a full scan. So really it involves 4 different packets. It looks like you're starting with the same, then your target missing is doing the SYNACK, then you're the attacker, you're sending the ACK packet. At the end, you're also sending the reset packet with acknowledgement. Okay, so that's how your TCP scanning works, and that's how your Wireshark looks like. Okay, now I'll let you guys debug some more, look at all these different protocols, look at all the different data if you are interested, but you have a good place to start. So let me uh, what I'll do, I'll just continue without saving. So I restarted the packet capture. Okay. So what we'll do now, so we have reviewed the full TCP scan, right? Now let's see what happens if I change that TCP scan to a SYN-SCAN, right? Which is a stealth scan. And in this scan, we said we do not send the last acknowledgement bracket. Okay. So let's start the scanning and let's see what happens. Okay. And it's still scanning. It takes a little bit of extra time when we scan with the stealth scan, but not too long. And now the scan is done. And what I see almost the same result here. So let's analyze these results as well. Or in this case, we also have, okay, a good bit of results. A lot of it seems very similar. I also got 21, uh, 80, 445, 631, PPP, MySQL. Couple ports that didn't show up in my TCP scan showed up in here, and couple ports which showed up in a full TCP scan is not present with the SYN-SCAN, and that's common, that expected. Okay, not every single type of scan will identify every single port. That's why you use sometimes different type of port. Another thing to note is my TCP full scan took 4 seconds. This one took 16.74 seconds. Okay, but both scans are useful, and particularly with this one, as I said, since we are not sending the last acknowledgement packet, if the firewall or IPS or IDS are misconfigured, uh, it's a stealth scan. It may not be able to identify that there is a port scanning activity going on. Now let's go back and look at the packet capture. Then now I can stop this capture. And in this capture, what I expect to see is pretty much the same packet all the time, right? There is no response. So to review more closely, let's use the same trick. So let's do TCP port. Let's look at packet 21. Let's see what is going on. It looks like packet 21, and what I'm really looking for, packet 21 and your I'm sorry, port 21 and your source. Let's try, and IP dot source. The source needs to be what, 192.168.1.23. Let's see if we have any. Yeah, there we go. So now if you follow, don't know if you can follow this packet. We might. TCP stream. There we go. So what is happening here? Okay, this is again the attacker's machine. This is my Kali box 105. I'm sending the SYN packet. That is the -s command with the nmap. I send the packet to the port 21. Okay, this guy, which is the box I'm scanning, okay, it is sending me a message back. It's saying, hey, I'm acknowledging the connection. So in a TCP scans, I would send a ACK packet here. But as you see here, we are not sending any acknowledgement whatsoever. We're just saying, hey, good that you're acknowledging, but just reset the connection. Okay, and you can check that what I just did with any other ports that we have identified, and you will clearly understand that in a scene scan, you're just sending scene packets a whole bunch. Then as soon as you receive a scene ACK, what are you doing? You're just sending the reset. That's why it's a half open scan, and we also call it a stealth scan. Okay. Now the last thing that we want to do, not maybe the last thing, let's look at the UDP scan. And UDP scan typically takes even longer. Okay. So let's do U, and actually I just do the default ports and just gonna remove this P from here, and I'm just running the scan now. Okay. So the scan is going on, and UDP scan typically a lot of time takes even longer. And let's see how long it takes. So for the TCP, we had about 4 seconds for TCP full scan, TCP half scan, which is dash SS. It took 16 seconds, and now we are doing UDP scan, and look at that. It's got 22, it took 22 seconds. Okay. But it didn't give me a too much of a result, right? It looks like there's no UDP port that's open, and it just says host is off. It gave me the MAC address, and that's about it. But didn't do too much. But your information that you get over here, that might still be useful, right? So over here, what I'm seeing, it's sending a lots and lots and lots and lots of UDP packet, and looks like some TFTP packets as well, which I typically don't use. Okay, so looks like that's how it's behaving. And let's try this, see if anything else shows up. So I'll go and increase the port number to say port 10,000. So let's see if anything else shows up. Let me pause the video so that you are not wasting time looking at, whatever number of seconds it's gonna take. I'll be back in a second. The scan is going on. I'm gonna wait for a few more seconds and be back. Alright everyone, it's taking so long that I decided, at least for this video, I would not explore UDP packet more than what we have. So one thing just I wanted to mention about the UDP packets, it looks like it's sending, your Kali is sending both UDP and the TFTP packets. So UDP is the protocol and TFTP is the trivial file transfer protocol. So it's trying to send probably a small IP packet to see what kind of response we get. If it says, hey, your port is unreachable, then it knows that, hey, the port is not available. But if it says no response, right, then it is going to think that, okay, the port is actually open, which will lead to a lot of false positives. Okay. So maybe do couple other things. Maybe let's run our nmap with the operating system detection command, which is simply just -o. And at this time uh, we don't really need our our packet captures anymore. Uh, so we'll just go back and we're just going to run this with the dash O, and this three, the next couple that we're going to look at, we are just going to look at our output. Okay, so over here what we are looking at, okay, so it gave us all the regular outputs that we have been getting, but this time here is the operating system details. Okay, it's saying is, hey, it's running Linux 3 point whatever version. uh, you have a Linux kernel version and operating system details. It's probably Linux 3.2 and 4.9. Okay. Now another thing that I like, as I said, here you got all the services, but you don't know the details of the services. Okay, and it's very useful a lot of time to run with S and then capital V for version. And notice what kind of data we get back and how detailed they are if we run this command. Okay, so I'm still running, and this time if you see at the after the services, now it is giving me, okay, this SSH is actually using the OpenSSH version 6.6.1 P1, and your FTP is actually using Pro FTPD version 1.3.5. This is very useful because now I know, okay, what is the vulnerability that are available with that particular version, right? Maybe the latest version of this service don't have any vulnerability, but if I know that someone is using an older version of this protocol, I can figure out what that is, and now I can start exploiting. Okay, so we have learned both the operating system dash O and dash SV. We have also learned that for service detection. The last one I sometimes also use is called A. A is for all, and that's also my favorite. We run this one, it's gonna give you all the results. Some people will say it's very noisy and you should not use it, but in a lab environment, it's okay. So if I run it with capital A, typically it gives me both operating system and service detail, all of that together. So I don't have to remember two different commands. Just one will give me what I need. So let's give it just a second. And that's really all I wanted to cover. Um, One last thing we might try. Let me go back and see if my system is still responding. Sometimes when I run so many different things, it just locks down on me. So it looks like that's what is happening. All right, just give it a second, and as soon as this scan is done, we can stop this video and let's just review as the scan is running what we have covered in this video again. So we have learned about Nmap. We looked at the TCP ACK, which is a full scan. We looked at the packet capture. We know that it's doing the full three-way handshake, and then at the end, it's also sending a reset packet. So 4 packets really. With the SYN, it's sending the SYN, it getting the SYN-ACK, then it's just immediately sending a reset packet. UDP, it's sending the UDP packet with a TFTP, which is a trivial file transfer protocol, is looking for this message ICMP port unreachable message. In our lab environment, we were not successful in finding any UDP port that were open. In your environment, you may find something. We also quickly looked at the operating system detection with the dash O flag, and we also looked at the service detection with the SV. Right now, we are trying to run the dash A, and look at that dash A gave us so much of information. Look, message signing visible, challenge response. It's a lot of information. Okay, it's very detailed. So that's one of my favorite that you have also learned. So you got the IP and the port and the version, right? And look at that. This information was not there before. Even what are the host keys? Okay, what kind of encryption it supports? All of that information is here. So that's one of my favorite command when I'm using my Nmap. And the last thing that we did not cover is just running this one, which is Nmap with the decoy command that comes with the dash D, where you can provide bunch of IP address, and it will not hide your IP. But if there's a firewall in your attacker's network, it will think like your scanning is coming from all those IPs, but really in reality there's only one IP that is actually doing the scanning. Okay, and we also looked at few of these uh, Wireshark search parameters to quickly locate your packet for say port 21. If TP was running, we use some of this to analyze some of the packets to understand it better. All right, that's where I wanted to end this video. It should be enough to get you started with Nmap and make it really useful. If you like it, just let me know. If you have any comments, please leave it in my comment window. Thank you.